Hi, this is Susie Poor, class of 2017, and this is my solution to problem number 43 on page 164 from chapter 6, Work and Energy. So the problem statement reads, the roller coaster car shown in figure 641 is dragged up to point 1 where it is released from rest. Assuming no friction, calculate the speed at points 2, 3, and 4. So the values we need from the diagram are h1, h2, and h3. So we know h1 is 35 meters, h2 is 15 meters, and h3 is 28 meters. So to start off, we're going to solve for the speed at point 2, or the velocity rather. So we know we need h1 because that is the height at point 1 where the car is starting. So we know it's a conservation of energy problem, so we make the statement UA is equal to UB. And we know at point 1 the car only has GPE, gravitational potential energy, because it is at rest on top of the hill. But at the bottom at point 2 it'll have kinetic energy. So GPE is equal to KE. Making the substitutions for their component parts, we have mgh1, so the height at point 1 is equal to 1/2 mv1 squared. That's the velocity at point 2, the first velocity that we are looking for. So the m's on both sides cancel, so we have gh1 is equal to 1/2 v1 squared. Dividing both sides by 1/2 and taking the square root, we have root 2gh1 is equal to v1. So making the substitution for the actual values, we have 2 times 9.8 meters per second squared, the value of gravity, times h1, so 35 meters, is equal to v1, and this comes out to be 26 meters per second as v1. Moving on to the velocity at point 3, we know we need h3, the height at point 3, so that's 28 meters, and we know we need v1 in this equation, so that we just found, so that's 26 meters per second. So again, conservation of energy problem, we make the statement UA is equal to UB, but this time the car is starting with kinetic energy from point 2, and it's ending with both gravitational potential energy and kinetic energy as it reaches the top of the hill at point 3. So making the substitution again for their component parts, we have 1/2 mv1 squared, so that's the velocity we just found at point 2, is equal to mgh3, so that's the height at point 3, plus 1/2 mv2 squared, so that's the velocity that we're looking for. Again, the m's will cancel, so we have 1/2 v1 squared plus gh3 is equal to 1/2 v2 squared. So again, we divide both sides by 1/2 and take the square root. So we have root 2 times 1/2 v1 squared minus gh3 is all equal to v2. Putting in the component values, we have 2, so root 2 times 1/2 26 squared minus 9.8 times 28, and this is all equal to v2, and v2 comes out to be 12 meters per second. Solving for velocity at point 4, so we know we're going to need the value of h2, so that's 15 meters, and we know we need the value for h3 again, so it's 28 meters, and we'll also need v2 that we just solved for, which is 12 meters per second again. So conservation of energy problem, statement UA is equal to UB, and this time at both points, the cart will have GPE and KE, so we make that statement. Substituting for their parts, we have mgh3, so the height at point 3, where it's coming from, plus 1/2 mv2 squared, the velocity at point 3, is equal to mgh2, so that's the height at point 4, plus 1/2 mv3 squared, so it'll be the velocity at point 4, what we're looking for. The m's will cancel on both sides, so we have gh3 plus 1/2 v2 squared is equal to gh2 plus 1/2 v3 squared. So to solve for v3, we have to subtract gh2 from the right side of the equation. So this will give us gh3 plus 1/2 v2 squared minus gh2 is equal to 1/2 v3 squared. So we have to divide both sides by 1/2, so this gives us 2 times gh3 plus 1/2 v2 squared minus gh2 is all equal to v3 squared. So taking the square root of 2 both sides, we have root 2 times gh3 plus 1/2 v2 squared minus gh2, and that's all equal to v3. So if we put in the actual values, we have root 2 times all of this, 9.8 times 28 plus 1/2 times 12 squared minus 9.8 times 15. This is all equal to v3, so the velocity at point 4, and this is going to be 20 meters per second.